Good afternoon, everyone. As you can see, I serve a dual purpose today, right? I mean, I try to moderate the online audience. Also, I volunteer to be a presenter. Today, thank you very much, Nick, for having us here. Julia, thank you very much, all the organizers, for this opportunity. Hello again, everyone. My name is Dimitrios Liparas. I'm a research and innovation manager from Netcom and Indrasoft, and I have the honor to serve as the coordinator of the PLOTO project. Together with Professor Dimitrios Vamvatsikos from the National Technical University of Athens, Professor Vamvatsikos is the scientific and technical manager of PLOTO. We have prepared an overview presentation of PLOTO. For the record, you can see the full title of the project there. I guess you will all agree that we just call it PLOTO without analyzing the title, which is too long. Two things I would like to say is basically I'm very happy to see that all three projects, namely PLOTO, Crystal, and Renew, are present here today, are represented. I think it gives a very good message that we will all move forward, synergetically towards achieving the aims of our topic, which is the climate resilient and environmentally sustainable inland waterway transport infrastructure. And also would like to say again hello to our project officer, Claudia, who I would like to thank her for being here with us today. So this slide, I mean, of course, some of the information was already presented by Crystal in the sense we share the same start date. Our duration differs from the other two projects. We have a duration of 42 months, so we're expected to finalize our activities end of February 2026. And as regards our geographic distribution of our consortium, we're 20 partners from 8 European countries, of course, with complementary expertise when it comes to addressing the topic, the objectives of our topic. So, in the next couple of slides, we'll see some, let's say, aspects and some challenges that led to the inception of PLOTO. So we go back to 2019. Of course, the starting point is the European Green Deal. When we think of the set of policy initiatives that were presented by the European Commission, if we drill down, we focus on the development of European green ports and multimodal hubs of the future. The point is not only to think of in terms of infrastructure, but we should take it to smarter approaches and more efficient, innovative technical solutions that will help us achieve sustainable management of goods and freight flows, but also seamless integration of the port community and inland multimodal terminal hubs. At the same time, balancing environmental effects and economic requirements. So, if we specifically, let's say, address the freight transport and logistics sectors, of course, it goes without saying that they are vital to the EU single market as well as for Europe's prosperity. If these, of course, sectors are well performing and dynamic, they can lead to an improvement of the overall productivity and competitiveness of the EU. Some interesting facts here is that, let's say, the global freight traffic is anticipated to triple for inland modes in the next 30 years. Plus, when it comes to the EU, surface freight traffic is expected to rise by 53% by 2050. When we think of, let's say, the growth potential for these two sectors, we can say that there are certain complications and certain aspects to be considered and to be taken into account. We have, let's say, saturated infrastructure, carbon emission goals that need to be met, as well as energy constraints in place. As a final take from these slides, let's say, smaller ports, especially smaller ports, are in urgent need of a concrete roadmap to sustainability that has ready-to-use cases. So we believe, of course, that especially smaller ports have the most to benefit from this topic, for example, from this project. So PLOTO aims to leverage existing tools and services, as well as emerging solutions, in order to develop an integrating risk assessment platform that can be primarily applied to inland waterways infrastructures. Let's say the three aims or goals of this platform, of our tool, of our key result, is to lead to a reduction of climate change-related risks, to improve the resilience of inland waterways, as well as to protect the biodiversity and other environmental parameters. From a methodological viewpoint, we're a purely technological project, of course, but we're driven by the actual needs of our end users. And we are driven, let's say, we proceed via the design of pilot activities, of course, the ones that are scheduled within the lifetime of our project. We strive to adopt an agile development approach and a startup mentality for our project. We plan, of course, to produce early prototypes. They will be validated with our stakeholders in intermediate schedules in order to have a continuous amelioration of our results. And of course, make common sense that we engage in the blistering team of experts. Otherwise, we wouldn't have a project in place, right? So our 3 use cases, they will take place in 3 different demo sites in Belgium, Hungary, and Romania. We don't have any, let's say, we don't drill down into the use cases per se. We will just say that case study A takes place in the Danube area, including the waterways and inland ports. The second case study takes place in Hungary, namely in the Budapest port area connected to the railway. Case study C takes place in the region of Wallonia here in Belgium. So we have, let's say, singled out 3 main objectives that we'd like to achieve through our use cases. 1, to improve multiple hazard assessment and strategic management for protection of the inland waterways, ports, and sections. Secondly, to improve the strategic and operational decision making. And thirdly, to test the various PLOTO outcomes in real-scale critical parts of the inland waterways. At this point, I will give the floor to Professor Vamvatsikos. Good afternoon, Dimitrios. Can you hear me?
Yes, yes, I can hear you.
Perfect. If you would you like to share your screen or?
Yeah, let's try to see how that goes.
Okay, like this. So I will just control the flow of slides.
Does it work?
Yeah, I mean, you let me know.
All right.
Yeah, thank you.
No, I can. All right. So a lot of the work in PLOTO concerns the assessment of our pilot studies, meaning we have essentially an inland, maybe I should make a better pointer. We have an inland waterway, and that includes, of course, the waterway itself and the fleet going through it and the facilities. And it's subject to hazards. Hazards can be earthquakes, it could be storms, it could be the general water flow throughout the channels. And the idea is that from the hazard, you would like to go to your assets, and assets include not just the waterway, but also the railway that is coming to it, includes the power transmission and supply of the system, water essentially, roads that come in and feed into the logistics systems of the port. And from the single assets, you will want to discuss networks of assets. The obvious one is the transportation network of inland waterway, but there's also the road network, the railway, and of course the electricity network and communications, meaning that you want essentially to interconnect networks and put them all together into a single model of the inland waterway and of course the hinterland, forming an entire digital twin. And the digital twinning part comes from the existence of sensors, which allow us, given their abundance and their existence both at the port and at other assets and wherever available, they give us the capability to figure out what is the hazard, what is happening as the hazard is progressing, if it's a hazard like a flow or water flow or a flood flow, and what is happening when we have detected hazard coming from upstream and coming to us downstream, for example. Now, one of the primary hazards here, and I guess a huge part of the proposal and the call itself, is the so-called climate change. In this case, climate change is projected through the IPCC RCP scenarios. There's the classic ones, the 2.6, 4.5, and then you can even go as up to 8.5, meaning as the numerics increase, it's a worse and a worse and a worse scenario, with the 8.5 up here going to pretty extreme, let's say, changes in the expected release of of CO2 and also climate temperature and changes over time. Mostly our focus is going to be 4.5, but we'll also do 2.6 and potentially even go to 8.5 in some cases. But mostly it's 4.5, which seems to be a more reasonable, let's say, projection of what we expect to happen in the next 50 to 60 years. Now, this allows us to focus on specific parts of Europe, where especially our use cases are, and figure out wind patterns, temperature, precipitation, and have knowledge of what we expect statistically speaking, okay, not exactly, but statistically speaking, what we expect our climate to be in the next coming decades. At the same time, we have hazards such as earthquakes, and earthquakes in this case are tackled by the so-called stochastic event sets, which give us the potential events that may happen in the next actually thousands or hundreds of thousands of years, averaged out to every single year coming up. Because earthquakes are not exactly easy to predict, actually, they cannot be predicted, they can only be tackled statistically. We are generating ground motion fields, essentially maps of how the shaking is going to be along the routes of the waterway and what damage and consequences this may have for our hinterland and also for the waterway infrastructure. Put this all together, the intensity measure fields, the exposure models, meaning what assets are exposed, and also the consequences to individual assets and to systems of assets, the so-called networks. You run them through a risk analysis engine, and you eventually are able to estimate direct and also indirect losses, meaning direct physical damage, but also indirect losses in terms of loss of business, downtime, loss of functionality. Put this all together, and you get, let's say, the favorite numbers that the insurance and reinsurance companies like to play with when they try to investigate what can happen in the future and how to best insure or further on mitigate it. And I guess that's it from me.
Thank you very much,
Dimitri?
Dimitri.
Thank you.
We will switch back to mine. Thank you. There are a few slides left in the presentation. We will quickly go through them to allow time for Renew, right, to give the presentation. Everybody's already thinking of the beers, right? So we have a slide on the target groups, the groups of stakeholders that we would like to reach out to and engage, let's say, in the project activities. Of course, it goes without saying, like the possible groups that we would like to contact and engage. Basically, the message here that this slide would like to give is that we'll do our best from our, let's say, viewpoint to engage all of them throughout the project lifetime. Again, I mean, I think it was already mentioned by Crystal, but we're at a very early stage of our activities, month 7 specifically. So we hope to be, let's say, next year, let's say in a future event, hopefully, I don't know, possibly here already, let's say, to renew our appointment for next year, to be able to present to you some concrete results, technical results, as they will start flowing from our technical work packages. In any case, yes, these are all, let's say, the stakeholder groups that we will try to engage in, let's say, the activities of our project. This slide, of course, gives the expected outcomes of PLOTO. I will not go through them in detail. I will just highlight, let's say, for example, outcome number 5. Let's say is possibly the main outcome of PLOTO, a modeling and simulation environment for assessing the resilience of inland waterways and potential impacts due to various hazards, which mainly will come as a result of, let's say, for example, outcomes 1 to 4. So when we achieve climate-aware crisis management, when we have risk models in place, able to assess the inland waterways elements vulnerability under multiple hazards, if we integrate also an analysis framework which will enable the flow of information from hazard to system risk/resilience. All of these, let's say, combined together will give us, let's say, the PLOTO risk assessment tool, the platform. which will also, let's say, lead to a number of expected impacts throughout our project. Again, I will not analyze them in detail. I will just, let's say, highlight, for example, the first two as possibly the most important ones. So PLOTO will aim to ensure, let's say, navigability for inland waterways by assuring at least 50% capacity during extreme weather events, as well as, let's say, we will aim to enhance the resilience of inland waterway infrastructure to extreme weather and human-caused events by assuring at least 80% capacity at network level during the disruptions. And of course, the last slide in our presentation, as it is aligned across all presentations, how we, let's say, contribute to the objectives of the NIADES 3 action plan, our impact map. So for 4 out of the 6 objectives, if I'm not mistaken, Nick, that are highlighted here. So we can say when it comes to shifting freight to water, through achieving, let's say, increased reliability of inland waterway transportation, we, let's say, highlight, let's say, the importance of how essential inland waterways is as a component in intermodal transport. So indirectly, we contribute to this objective. When it comes to the pathway to zero emission fleet, we believe we directly contribute to this through ensuring business continuity and through achieving resilience of waterways, infrastructure, and ports. So through this business continuity and resilience, we contribute to energy efficiency, also leading to the pathway to zero emission fleet. More attractive jobs, of course, we directly contribute to this objective by offering a gender-balanced training of young engineers for inland waterway employment. This is already taking place through, let's say, the involvement of our end users, for example. So this gender-balanced training is already offered throughout the project lifetime. Smart waterways, which we believe we have the most direct impact and strong impact to this objective. We believe we offer several digital elements that are most certainly needed by inland waterways, the inland waterways transport sector. For example, we have UAV and satellite monitoring of waterways. We offer an incident management system and also near real-time risk assessment functionalities. All these elements, of course, contribute to the digitalization of the inland waterways transport sector. So that's all from our side, from me and Professor Vamvatsikos. I would like to thank you for your attention, and we can, of course, take any questions you might have. Thank you very much.
Any questions, remarks? Were the pictures okay? Excellent. Digital twin questions?
Just one question about the data management and a learning system, because there is quite a variety of incidents that happen over time, and also the effects spill over time. So do you keep track of that in that sense? So how severe blockades, or even in terms of droughts, and I think by monitoring this over time, we can learn from it and how to improve and to deal with incidents.
I would like to
I hope it's not too long because
Professor Vamvatsikos to come to my rescue. Dimitrios, are you still
actually,
here with us?
Yes.
Thank you.
The incident management system actually does keep track of these events. It's not automated. I will not claim that it's an automated thing that automatically figures out whether an incident happened. It's more like a user reporting. But yes, it keeps track and it keeps a map of where such incidents have happened over time and where. But of course, just for the use case, okay, whatever is included in the use case, yeah, that happens. So it's accurately part of our history, and we want to keep track of it because that's what in many ways tells us the functionality of our waterway.